Okay, Science 10, let's look at double replacement reactions. Now in a double replacement reaction, both this metal here will kick out this other, often it's a metal, in this case it's a hydrogen. So essentially they're going to change places. The aluminum and the hydrogen are going to change places. For this one here, we're going to get this hydrogen and this calcium changing places. You're going to want to be focusing in on, often with these, the table of common polyatomic ions, and always consider these just a single unit. So our SO4, and you will find SO4 over here. You just have to look carefully for it. There we go, sulfate. And PO4 is right here, and we will also find PO4. There it is, phosphate. So again, you're just going to want to know that, you know, essentially it's like a little do-si-do, a square dance. This partner here is going to go and now dance with that one, and the calcium is going to go and dance with the SO4. Same here, this hydrogen is going to replace this NH4 or ammonium. I think we've got a couple more down here, just one more. So this calcium is going to change places with this sodium. So ultimately that's kind of an overview of these ones. Let's do them together. Again, make sure you've got your periodic table. You're going to also want your solubility table for these ones as well, because your products, you're going to want to know whether they're soluble. Notice how they are all aqueous. This is a great way for reactions to happen, right? In water, in solution. And, you know, some of these, if they're going to produce, say, hydrochloric acid, for example, that's going to be a gas. So yeah, you'd want to do this in solution to be a lot safer. But yeah, let's get underway. So aluminum is going to combine with sulfur. So we better get sulfur here from our periodic table. So let me just quickly grab that. Again, you want to make sure to have your periodic table handy, and just grab my thing. We find our sulfur. Oh yeah, it's -2, meaning it wants to accept 2 electrons. Line that up over here. Okay, so essentially it's going to be aluminum combining up with sulfur. It's going to make aluminum sulfide. Let's get the proper formula for that. Simplest ratio between 3 and 2 is going to be 2 aluminums, 3 sulfurs. So let's just write that right here. So Al 2S3, and this is going to be a solid, I believe, according to the solubility table. It's only group 1 and group 2, and ammonium, either than that, it's low solubility, so that'll actually form a solid. Okay, and we're worried about balancing after we get the formulas correct, but definitely that first one, aluminum sulfide. So now the hydrogen is going to link up with the chlorine. Well, that's just good old HCl, hydrochloric acid. And that's definitely going to be aqueous because we're in solution here, AQ. Let's just write that so it fits in a little bit better here. HCl, AQ, there we go. Got a little bracket. All right, now we need to be balancing this. Now, you know, look at the sulfur here. There's 3 of them. There's only 1 there. So that's one kind of a, if you like, a problem. 3 chlorines here, only 1 of them there. Really, you want to start with either that sulfur or the chlorine. And, you know, if starting with the chlorine makes this hard, then just scrap it, start with the sulfur. I'm going to start with the sulfur. I just have a sense that that might work a little bit better. I'm just going to erase this this little arrow, which was showing us that indeed it's a double replacement. There we go. Okay, so sulfur. So basically, if I put a 3 here, okay, got 3 sulfurs, 3 sulfurs. I got 3 times 2. I've got 6 hydrogens on this side, so let's put a 6 right there. Okay, so far so good. And so now we want to try to get our chlorines balanced. 6 HCl, so they're going to be 6 chlorines. So let's just put a 2 here. Oh, look at that. That 2 aluminums, 2 times 3, 6 chlorines. So that's good. And 3 times 2 hydrogens, 6 hydrogens here, 6 hydrogens there, and 3 sulfurs 3 sulfurs. So we'll just put a 1 here. Read it out, 2 aluminum chloride, 2 moles of aluminum chloride, and combined with 2 moles of hydrogen sulfide. It's going to give you 6 moles of HCl and 1 mole of aluminum, solid aluminum sulfide. Let's flip to our next one. All right, in this next one, we've got H2SO4. That's an acid. Let's check again on your periodic table. You should have some of these common acid names written down on the back. Oh, that's sulfuric acid. There's also the process to figuring out the name of an acid, which we won't go over here, but we've got videos in the course on that. So we've got sulfuric acid, and we've got calcium PO4, calcium phosphate. Have your table of common polyatomic ions handy. It's right with your periodic table right there in the center at the top. So those two are going to come together. It's going to be a double replacement. So the hydrogen is going to go with the PO4 or with the phosphate, and the calcium is going to go with the SO4 or the sulfate. All right, so let's just begin. Again, make sure you know this is sulfuric acid. And I think we're going to get an acid coming out on the other side as well. And we're definitely going to need the solubility table here whenever we've got the polyatomic ions. Again, keep these polyatomic ions intact. Don't break them apart. Let's look at the charge first on hydrogen and the phosphate group if we're going to combine those two. So hydrogen is +1, phosphate is PO4. And it's -3. This is going to be an acid. Actually, it's going to be called phosphoric acid. But let's get the proper formula for this. We're going to need 3 hydrogens and 1 PO4. So H3PO4, and that is definitely going to be aqueous. We can see that here as well in the solubility table if you check it, and make sure you've got yours in front of you. We're finding either hydrogen or phosphate at the top. There's the phosphate right there. Group 1, highly soluble, hydrogen's in group 1. Okay, definitely that is an aqueous. Next, we've got to get the formula for when the calcium, the calcium is Ca +2, combines with the sulfate. And sulfate is SO4, -2. Oh, that's good. That's a nice 1-to-1 ratio. So that's just going to be Ca SO4. I'm just going to write it up a little higher. We don't quite have enough room on our little sheet here. Ca SO4. Now the state of that one, let's check our solubility table. Looking for either calcium on top or the SO4, in other words, the sulfate. And we got SO3. Oh, there it is. Oh, most things, but let's see, calcium. Oh, this is going to be low solubility. This is actually going to form a solid. This is going to precipitate out. So we're going to get a nice precipitate out of this reaction. So if you're going to see this reaction, two liquids would be poured together, and then a precipitate, sort of a cloud, would form in the water, or the solution would be water, obviously. So that's what this reaction would actually look like. You'd know that a reaction had happened because a precipitate had formed. Next, we want to start balancing this. And ultimately, it looks like the hydrogen is kind of out of whack here. And yeah, let's just try to take this to town. If we're going to, also the phosphorus. You know what? Phosphorus, there's 2 of them. Not phosphorus, sorry, the phosphate. There's 2 phosphates here. There's only 1 there. Let's put a 2. I think that'll also help us with the hydrogen because 2 times 3 is 6. So there's 6 hydrogen. There's definitely 2 phosphates. So the phosphates are good, but 2 times 3, 6 hydrogens on this side. So let's put a 3 there. 3 times 2. Okay, so now we've got 3 times 2. We've got 6 hydrogens here. 2 times 3, we've got 6 hydrogens there. We've got 3 sulfates here. We're going to need 3 here, but guess what? We also need 3 calciums. So this is going to work out quite nicely. 3 calciums there, 3 calciums there. 3 sulfates there, 3 sulfates there, and 3 calcium, yeah, 3 calcium, phosphate, 2 of them, 2 of them. So I can just put a 1 here. So this is 1 mole of sulfuric acid. Sorry, 3 moles, got to read it correctly here. 3 moles of sulfuric acid. 1 mole of calcium phosphate is going to give us 3 moles of calcium sulfate and 2 moles of phosphoric acid. So that is phosphoric acid. Let's just move on to this next one here. All right, next double replacement reaction is right here. Calcium nitrate, again, have your polyatomic ions, and indeed make sure to say the names of stuff. Calcium nitrate and sodium PO4, sodium phosphate. So it's going to be calcium replacing sodium, so it's going to be calcium phosphate, and then sodium nitrate. Let's start with that calcium phosphate. Let's do a little bit of rough work off on the side. So calcium is +2. Check your periodic table, the common polyatomic ion there for phosphate, PO4, and you're going to see it's -3. So, you know, get a common multiple between 2 and 3 is 6. So therefore, you're going to need 3 calciums to 2 phosphates. Let's write it out. Ca. Yeah, Ca3. Put the phosphate in bracket. PO4. 2. And again, that would nicely balance it off, right? If we had 2 -3s, that would be -6. If we had 3 -2s, that would be +6. Makes a nice neutral molecule, very large molecule indeed. What's the state of this? So we've got, look for calcium or phosphate up here. We've got, I think, phosphate off on the side. There it is. And group 1, and ammonium, but nobody else. So this is low solubility. This is going to form a solid. So if we did this reaction, we would observe a precipitate forming, or we could predict that right now. And we're just going to need to kind of squeeze it in here. Maybe actually I'll just move my my solubility table over just a tiny bit. Just let me zoom out for a second. Grab the solubility table just to give us a tiny bit more room. There we go. Zoom back in. All right. Again, the calcium kicked out the sodium, so now the sodium is going to go where the calcium is, so it's going to be sodium nitrate. Let's check what the formula should be for that. So again, just do some rough work off on the side. Na is +1, sodium's +1, and the nitrate, looking right on my common polyatomic ion here, NO3 is -1. Oh, nice, a nice 1-to-1 ratio. So we're just going to get good old sodium nitrate, NO3. Is that soluble? Yeah, everything is soluble in nitrate, aqueous, AQ. That's your first check, and definitely check it that you've successfully written these 2 formulas correct. So take your time, make sure these 2 formulas are done correctly. Ultimately, we're just balancing the charges on the ions like we do with all ionic compounds. So as long as these 2 are correct, we can now balance this. And if you're having trouble balancing, it might be that these formulas are incorrect. So always check your work, check it multiple times to make sure it's correct. Let's look here at this right here. 3 sodium, 3. I could just put a 3 there. No, that's not going to work, because if I put a 3 there, that'd be 3 nitrates, and there's 2 here. I need a common multiple here for these nitrates, and I can't just put a 2 there, right? Because if I put a 2, because there's 2 nitrates here, but if I put a 2 here, that's not going to match the sodium 3. So we're going to need a common multiple. It's going to be 6, right? We're going to need to basically put a 6 here. Get 6 sodiums. I'm going to have 6 nitrates. This is going to start to work out, and you'll see. So I'm going to put a 2 here. So I got 2 times 3. I got my 6 sodiums. And oh, look at that. I've got 2 phosphates. That was also able to balance the phosphate off. And so now let's just balance off our nitrates over here. Again, I've got 6 of them on this side, only 2 of them there. So if I put a 3 there, oh, look at that. 3 times 2 is going to be 6 nitrates. I've got 6 nitrates there, but the calcium is what I saw right away, that it balanced the calcium. I need 3 here, and I've got 3 there on the left. Again, conservation of matter, conservation of mass. The number of atoms on this side has to balance the number of atoms on that side, and it does now, and it's in a nice simple ratio of 3 moles of calcium nitrate combined with 2 moles of sodium phosphate will give us 1 mole of calcium phosphate, which will be a solid, it'll be a precipitate, and 6 moles of sodium nitrate. Okay, that's our double replacement reactions. Do these same exact reactions again on your own. The basic process using your periodic table, getting the correct formula for the products. Once you get the correct formula for these products, then the balancing, well, is possible. Without the correct formula, the balancing is frankly not possible. Definitely try these again and get the process. Take care, Science 10.